Hey everyone, I want to talk about a set of math functions which I would call rounding functions. You could also call them approximation functions or partial removal functions or truncation functions or whatever. I don't know. I'm going to call them rounding functions because it all kind of comes back to a common thing that we learn very early in our math classes in like elementary school or primary school or whatever, whatever's like the first kind of classes for you when you're very young. And a lot of these functions you start to learn when you get into the higher grades. You don't really learn it in elementary school. You learn them, if you get into programming for the first time, if you're getting into game development, you'll learn about these things. And for some people, they might not fully understand them or, might have some questions, but they kind of leave them unanswered. And what's interesting is this subject is very simple, very basic. So hopefully this video will answer a few questions that some of you might have. So the first of these rounding functions that you will encounter, and this is something everyone has already encountered before, is the round function, or just the concept of rounding. And normally how it goes is that you have a number like 5.73, and it could have whatever digits, whatever amount of digits. But when you round this number, what it ultimately gets rounded to, in this case, by default, it'll get, you're going to basically round to the ones digit, and you are going to you're going to compare, you're going to look at the digit to the right of the digit you're rounding to, and you look and you say, is it 5 or greater? Is it 5, 6, 7, 8, or 9? If it's one of those digits, you basically round up. If it's 4, 3, 2, 1, or 0, you round down. Or in other words, you basically do nothing with the digit, at least for positive numbers. That's a foreshadowing. So, in other words, if you round this number, you're going to get 5. Or, oh no, I'm sorry. You get 6. You get 6, actually, because it's 7. Now, let's say, for example, instead of rounding to the ones place, if you round to the tens place in this case, well, you're going to round to this, so you're removing everything to the right of it. So you look and you say, hey, here's the 3. 3 is a pretty small digit, so we're just going to round down in this case. And so the round of this would be just 5.70 or 5.7. So, of course, as you know, you can round to whatever decimal place, whatever digit place you desire. But by default, it's, you're rounding to the ones place. And the same thing is true for negative numbers. When you round, like, say, negative 1.23, when you round that number, you're rounding down. And so, like, if you round negative 1.2, right? Rounding this down means that ultimately it's going to become negative 2. That looks weird because you'd think, hey, it looks like the number's getting bigger, but in actuality, it's getting smaller, and that's what's important about rounding. You're basically going to the integer that you're closer to, or whatever value you're closest to when you're rounding at whatever decimal place. Now there are two other, and this is kind of the main part of this video here. These two next functions, which if you're someone who's a beginner programmer, you've heard of these before, and you may have some questions depending on your level of experience. And so that's why I'm making this video. And those functions are called the floor function and the ceiling function. And I think the names are quite useful and quite powerful names. They could have just called them always round down and always round up, but that's a little bit more verbose. It's a little bit more, wordy, and it could be written in a much more simpler way, and that's why they're called floor and ceiling. And also in mathematics classes, if you ever take a discrete math class in college or in high school, if they have those, you'll see symbols like this. And so basically, you'll have basically these kind of walls, if you want to think of them like walls, written in some math equation, and you'll have some numbers inside the walls. So if you have little bars on the bottom, that's floor, little bars on the top, that's ceiling. And so the floor of 5.72 is actually written, the answer would be 5. And the ceiling of 3.26 is actually 4, which is really weird because you'd think normally if you were rounding this number, it's going to be 6. And if you round that number, it's going to be 3. But floor and ceiling are a little bit different than the round function, because the floor function, and this is the key, is that it always rounds down. You're always rounding down. With the ceiling function, you're always rounding up. And this is interesting because a lot of beginner programmers, including me, would look at the floor function and say, hey, you're just always removing. You're always removing the fractional component when you floor a number. Whereas rounding sometimes makes the value bigger. Okay, and so you think of the floor function as a method to remove, and a lot of programming teachers might even suggest to use it that way, and you can, but you can actually run into some issues if you allow yourself to think that this floor function is specifically for removing the fractional component, for removing the decimals from a number, if, say, you're converting a float to an integer. And I will show some examples on my computer here in a bit. But I'm going to, just before I do that, I'm actually going to show you what I'm talking about. So if you do something like, let's say, floor, and I'm going to write it now in kind of like programming notation. If you say something like floor 37.64, right, the floor of that is essentially just 37. Now, alternatively, if, let's say, let me write some different numbers here. If instead this is negative, we'll go negative 2.63, right? You say, well, what's this? Well, some people might say, well, it should be negative 2 because it's removing the fractional component. Well, no, it's not actually going to do that. So the answer is actually negative 3 because, like I said, floor always rounds down, always, okay? If you remove the fractional component from a negative number, the whole thing's negative. Keep that in mind. The whole thing's negative. So if you remove the fractional component of a negative number, what you're doing is you're actually making the number bigger. You're rounding up, in a sense. And you don't want to do that in this case. So that's why it's negative 3, right? Negative 2, if you want to think of it this way, negative 2 plus negative 0.63 is equal to negative 2.63. Look at that. What you're doing by removing the fractional component of something, depending on whether it's negative or positive, you're either making the number bigger or making it smaller, depending on whether or not it's negative or positive. And this is an important idea to keep in mind with flooring, and that will essentially bring us to the next part of this video, which is truncation. So truncation is another thing which you might encounter less often, but it's something that basically I would say exists in almost any language that has floating point values and integer values. And you might not always see this function like written out this way. It might exist in some other capacity. But basically, I'm going to write it as such. Trunc, which is short for truncate. And you can look up the definition of truncate, but I believe the definition is just basically to remove a piece of a whole, leaving some remaining component. And so the truncation function is a little bit different from the other three functions that I've shown, and I will show how it's actually very specifically different. But the truncation function has the specific job of removing a piece of a number. So if you have a number like, let's say, 569.0642, some number, some large convoluted number with a lot of digits, what the truncation function will do if you truncate that, like this, is the result is going to just be 569. Of course. But if instead it was a negative number, it's still going to be 569, but with a negative, okay? So it's basically the same thing. But what's interesting about this is, like I said, the floor function from before always goes down. It always rounds down to a smaller number, and the ceiling function always rounds up, okay? And in this case, the truncation function, it doesn't even consider whether the value is going up or down. It removes the fractional component always. And so if you have something like this in a programming language, you can use this, to basically convert a float to an integer. And I think this is the best way to go about it. But there are some cases where the floor and ceiling function might actually be more useful. One example I can think of is that in procedural generation, in random level generation in video games, the floor function is used quite a bit. because what it does is it can take, some sort of continuous space and basically break it up into discrete, individual, countable pieces. And hopefully I'll have the chance to show you that here in this video. So stick around. Now, there are other things you can do with the truncation function, actually. If you have this function, if you have this ability, what you can then do is you can actually basically get the fractional component. Some languages do have a function called frac or fract, F-R-A-C, and they basically allow you to get the fractional component of a number, but you could actually do that with the trunc function, because the trunc function always gives you the integer. So what you can do is you can say, in a more algebra written sense, you can say x minus trunc x, and this gives you the integer component of a number, and this is the whole number. So if you take the whole number minus the integer number, you're obviously going to be left with the fractional component. So if you have this ability, if you have this function, this ability to truncate, but you don't have a function to get the fractional component, well, that's all you need to do to get the fractional component. It's that easy. But I will say that in some cases, this is very similar to another function which you might have heard of, called the modulo function. And these functions aren't, I would say, they're not really in the category of rounding functions, but they are very important ideas. But you will see, interestingly enough, if you graph it out, you'll see that the mod function is very similar to the frac function. But anyway, that's not relevant, so I won't go too off-road with that. But yeah, so now I'm going to switch over to my computer here, and we're going to see these rounding functions in action and actually compare and see how exactly they're different. All right, so I'm here on my computer, and I set up a very simple program here to basically print out the results of these 4 different functions. We have round, floor, ceiling, and truncate. And the one thing I want to point out, what's very interesting, is as you can see here, truncation, at least in C#, so I'm using C#, by the way, but you could, these things you could most likely do in various other similar languages. But as you can see here, the truncate function I'm actually representing by basically taking a floating point number and casting it to an integer. There's probably better ways to go about it, but that's a commonplace way of going about it. I believe in C# here, there is in fact a truncation function. Yeah, truncate. Calculates the integral part of a specified single precision, blah, blah, blah. You get it. So there is in fact a specialized function. I don't know which one's more performant. They're probably basically the same thing. The one is just more descriptive. This is, I would say, a little bit less descriptive in terms of, looking at it and being, oh, I know what's going on there. They're truncating deliberately for a purpose rather than converting a float to an integer. But behind the scenes, what happens when you do this is you're truncating, essentially. And then, of course, we have a round function, which in C# there is actually a version of it where, as you can see, you can specify the digits, how many fractional digits you want to round to. So if you want to round to the hundredths place, if you're, doing currency and things like that, you can. And there's even a midpoint rounding enum thing, which kind of goes into how all of these functions are actually very similar. They all are the same function, just different variants, if you will. And I'll show you what I mean. And I'm basically looping through to show different examples. So we'll run that, and we'll see what we get. So as you can see, we have here a couple different results, but the one that I want to look at here is 1.375. So I just kind of looped through and picked different values. But you can see here, if you're rounding negative 1.375, actually the closer value is -1. I think earlier I said something about, in this case, it would round down. But technically, it actually rounded up here because of the fact that you're closer. That's ultimately what rounding is doing, is you're just rounding to whatever integer is closer in this case. Flooring, of course, as you can see, it's always rounding down, so -1.375, it rounds down to 2, and ceiling rounds up. And the truncation function, as you can see here, always removes. It always, always, always removes. So if we scroll down and we go, to, I don't know, a different number, like, I don't know, here you can see -1.875 removing. If we scroll down here and look at some other results, you can see, 1.875 rounds up, obviously. Floor rounds down. Ceiling rounds up in this case. And truncate just removes the component. So that's, pretty much it. the reason why I'm doing this is because I want to encourage people to ultimately test very simple things. Some things might seem very mundane, very boring, things to do, but it's obviously very important to uh, experiment, and figure out how exactly things work and to understand basically how they work. So next up, I actually want to open up a graphing calculator and actually show what these functions look like graphed out, because sometimes getting a visual representation is even more powerful than just looking at these kind of console results. So I've opened up Desmos here, and the first function I'm going to show is the rounding function. So like I said before, it looks like basically a bunch of staircase. There's these kind of discrete places where, for these values, it's all 1. For these values, it's all 2, so on and so forth to infinity. And what's interesting is that if we look at now the floor function compared to the round function, you'll see that the floor function basically looks like the round function except shifted to the right, which is really interesting, because when you think about the rounding function, if you're a programmer, beginner programmer thinking, how would I code a rounding function? You might say, well, I'm going to do some sort of comparison. And that's a totally fine way to go about it. But it's kind of interesting because, really there is a more efficient way to go about it. You can just use the floor function and then somehow shift the value. And if you look at the ceiling function, which is this green line here, you'll notice that basically it's the blue line, which is ceiling, or flooring. Flooring is the blue line. The ceiling function is just the blue line shifted to the right, or to the left, I should say. And the rounding function, surprisingly, is actually, if you notice, is actually just the line that's kind of in between. So if we make it a little bit thicker here, you can see the red line is the rounding function. So essentially the rounding function is just kind of a in between, in a sense, of flooring and ceiling. It's kind of in the middle, and that makes sense because ultimately we're trying to round to the closest integer. That's what the kind of core purpose of the function. And you can see here, right in the middle of this line, you have 1. Makes sense, right? You're trying to get to the closest integer, and it makes sense. 0.5 is the number furthest away from its nearest integers, in a sense. Now, I might not have said this before, but there is actually, again, a generalized form of, and I kind of just said that now. There is a generalized form of, all 3 of these functions. And so that's this purple line here. And basically, as you can see, I've given it a slider, a value slider. So if I drag this slider, you can see the whole thing just moves. It shifts from left to right. And what's interesting is, it's just a floor function. So if you have a floor function, but you don't have a ceiling function, all you have to do is take the value of the floor, whatever you input into floor, and you basically just add 1 to it. If you add 1 to it, it becomes the floor. If you add 0.5 to it, you get the round function, as you can see here. If you have a floor function and you just take whatever your input is and you add 0.5 to it, it essentially becomes, the result essentially acts as if it was a round, which is very interesting. And of course, floor, well, to approximate floor with floor, it's just going to be a 0, obviously. So there you go. They're all the same function, but like I said, different variants. And the last function I want to show, of course, is the truncation function, which is a little bit different. And it shows really what its purpose is. As you can see, I've actually built this function. I had to make it manually. They didn't have a special one in Desmos here. As you can see, the one thing that's unique and interesting about this is that there's this big area in the middle. There's this big area where you can get the number 0. And it makes sense because, if you have a number like negative 0.81 and you truncate it, you're obviously going to get 0. And I think that speaks to really the kind of one of the paradoxes, in math, which is that, is there really such thing as negative 0? I mean, I guess there is to some extent if you think about infinitesimals, but if you don't know what an infinitesimal is, that's okay. You don't really need to know that until you get into calculus. But infinitesimals are very interesting. But regardless of that, outside of that, really, this truncation function really just shows how all of these things are different. Ceiling, floor, and round, they all are basically the same, except truncate is a little bit different. It has the same job, but it does it in a very slightly different way. And that just goes to show, what places truncation is important. So if you're specifically trying to remove the fractional component of a number, you want truncation, whether it be a function or maybe it's, casting like this. Uh, I think one of the core messages I want to get across here is that, well, in whatever programming language you're working with, chances are this right here does not give you the same result as this right here. You do not get the same result. This is not the same as this. That's probably the one reason why I made this video, honestly, of anything. So thank you all for watching. Hopefully this video isn't too long. I'll find out in a minute here. But yeah, truncation and floor are not the same. So that's pretty much all I wanted to say in this video. So thank you for watching, and I hope you learned something.